video, we'll take a look at how to conduct a t-test of independent samples in Excel. You should have knowledge of bell curves, histogram, and then, of course, mean, median, mode, kurtosis, and skew. We'll go over that briefly here. But let's assume that you are selling in Amazon. It can be whatever you want. And you used automated ads for your business. And so you just basically went in and paid Amazon daily, so over 18 days. And for your business, let's just say that you paid them the same amount every day. Let's say it's $25 a day was your budget. And you're looking at how many people saw your ad. And you just let Amazon do what it does. So it ran its own fancy algorithm or whatever. And these are how many impressions you got a day. And at the end of this, you had 2,314 impressions. So that's how many people saw your advertisement, and your average per day was 129. I also ran Descriptive Statistics, which you can download for free in Excel, and we got some output to let us know if we're normally distributed or not, which we'll get to in a minute. So group one, we just let Amazon do what it does. And it might help to look at this as almost like a placebo group. In this case, we're just letting Amazon do what it does, and then we're going to add a treatment to see what the effect is. In other words, in this case, we're going to manually get in there and tell Amazon who we want to target. So you just let it ride in this group. So this is kind of your baseline, if you will. You just let it do what it does, and you went in and modified and changed it, and you're going to see if your treatment, if you will, had an effect. You could also look at this like a drug trial. Imagine you got the placebo group here and the actual drug here. You're seeing if the actual drug has an effect. Same concept. So you targeting your customers in this case is the treatment. You did it over 18 days as well. Same budget. You have at the end of the day more views, and you have more views per day. So right off the bat, it looks like, wow, me getting in there and telling Amazon who to target, my treatment worked. Now we want to figure out when we're t-testing, did this actually happen by chance or not? So in other words, you could ask, is the manual group statistically different? In other words, is me manually entering things, is that statistically different or not? Now, you would, before you do all of this, I'm kind of out of order here, because you would run a hypothesis test on this. So you would essentially say there is no difference between the group means before we did our calculations. And then you would also look at there is a difference between the group means. So you would have your null hypothesis, there's no difference. And your alternative is that there is a difference between the groups. And right off the bat, this would tell us there is. You would do this, of course, after you set up your hypothesis test. Anyway, you got your automated group mean. Again, you had 129 a day looking at your ad. You have a standard deviation of 20, so most of the time you'll have between 128 plus minus 20. You'd be a standard deviation from the mean. And for a t-test, you should be normally distributed. And in Excel, you take a look at your kurtosis and skew. If both are between -1 and 1. Now here you can see that we're a little bit flat, if you will. Our kurtosis is -0.8. You'd be at a 0 if you had a perfect peak, if you will, and your tails were weighted perfectly to look like a bell curve. This would be 0. No sample is going to be perfect. In your skewness, you're going to be slightly right skewed because you're not at 0, but you're between -1 and 1. So I would say you're normal enough to run a t-test on this. And also you run a t-test when you got samples of less than 30. Once you get greater than 30, you get into z-testing. Many customers will actually require you to hit at least a sample size of 30 so you can run a z-test. And then let's take a look at the manual, our mean, our manual targeting. So we got almost 139, just slightly over for our mean. Our standard deviation is 26.735. So we're a little bit more loose, I guess. Our deviation's a little wilder, if you will. We're deviating a little bit more. And so we're going to be between 139 plus minus around 27 on average. And then our skewness or kurtosis is flat again. We're a little bit flat. Again, our bell curve would be more like this is, I don't know if this example works well, but you'd be a little flat, more like the Appalachian Mountains versus like if you were too peaked, you'd look like the Colorado Rocky Mountains. And you want a nice, perfect bell curve, so it would be flatter than that with this, but we're still closer. We're not greater than -1, and our skewness is almost perfect at 0. So in this case, I'd say we're normal enough. We're normally distributed enough, and so we can run a t-test on this. And so, and yeah, that should be about it for that. And let's go ahead and run it in Excel. So we got our data analysis. Let's go ahead and again, if you don't have data analysis tool pack, you can download it for free. There's plenty of videos to show that. Macs or PCs have it. And we're going to take a look at, we'll just assume equal variances, because let's just assume when we did our hypothesis that we're just assuming they're equal. And so we're going to hit OK. And then our variable range 1 is here. So it's group 1 basically. And then our treatment group is here. And when we're doing an applied method like this, we're just going to look mostly at the p-value here. We're going to look at what our p-value shows. And I'll just have my outputs. I'll just have my output go into a new workbook. Alpha is kind of the industry standard, 0.05. We're going to test it at a significance level of 0.05. We'll just hit OK and see what happens. So the first thing, most of the time, if you're not quite sure the tail on which way your treatment's going to go, you would just run it two-tail. So if we need to open this up here. Okay, so we have our means. We've already calculated this. If you go back to our other sheets, I've already calculated the mean, so that's nothing new to us. And then our variance is the standard deviation, and we're going to square that. That's how we get that. And then we each had a sample of 18 days, of course. And then degrees of freedom is if you do it old school style. So if you're looking at like the tables, the t-test tables in like a statistics test textbook. Again, I highly recommend learning the math behind all of this. This is an extremely applied example. And we're going to take a look at our p-value. We'll say two-tail here. And so this is kind of what we're looking for. Now, you can use the t-value as well, but just in our case, we're going to say, is the p-value less than 0.05 or not? So in other words, we tested at a 95% level of confidence or confidence level or a significance of 0.05. You're looking to see, is this less than 0.05? It's almost there if you one-tail, but not quite. So you would almost go with the null hypothesis here, is that this happened by chance, but you're really close if you use a one-tail. But what you want to also look at, so in this case we would say that the means were not statistically different, so you would assume you'd fail to reject the null hypothesis. One other thing you could look at either way is you can look at the effect, especially if you have a statistical difference. And we'll just do an effect size calculator really quick. This is on. And finally, our standard deviation. Again, that's why I recommend running the descriptives on it as well as just the t-test. But there we go. We can calculate. And if you're basically looking for, here's your Cohen's d. So we have about a moderate difference. So even though we weren't statistically different, the second group is moderately the the effect size is moderate. So a 0.2 would be like a slight effect. 0.4 would be moderate, and then point 0.8 would be a large effect. So almost similar to the correlation coefficient, but not quite. But that would be effect size. So that you would definitely be concerned with this if you were statistically significant. In this case, we are not. But that's how you run a quick t-test, and then you can do your effect size. This is totally applied, and I hope this helps you in your journey.